This is Algebra 2 with trig, 2b.5b. We're going to be factoring, solving for the zero terms, and then we'll talk about how to use the graph with that. Before we do the actual graphing, we're going to slide back one page, and we're going to answer our last two questions for solving polynomials on this side. So we're looking at 2x to the fifth power equals. So I don't want to bring my 2x to the fifth power to the right because that's going to give me a negative leading coefficient. So I'm going to subtract the 12 to the left and the 16x to the left. So that's going to change their signs, and that's going to leave nothing on the other side. So now we have a fifth power. Well, we don't have any special rules for factoring fifth powers. We don't have any special rules for factoring fourth powers either. But if you take a look at this, there is an x in every term. So we're going to factor out a 2, because these are all even numbers, and an x. So this is x to the fourth minus 6x squared plus 8. Now I said we didn't have any special rules for factoring fourth powers, because we're not going to treat it differently than we do a quadratic. We're going to treat this just like a quadratic. Notice that this is a 4. As long as our b term here is half that amount, we can factor it just like a quadratic. What multiplies to be 8 and adds to be 6? We have 4 and 2. Negative 4 and negative 2 make positive 8 and add to be negative 6. Now the question is, what's going to have to happen here? For them to multiply together to be x's, they have to be x. And for it to become a 4, they have to add to become 4. So that's going to be 2 and 2. We know it's not anything different than 2 and 2 because when we multiply the outside and the inside, they have to be like terms that add up to be negative 6x squared. That works out great. Don't forget your GCF, and be sure you keep making it equaling to 0. Now this is x squared minus 4. That can still be factored apart. That's the difference of two squares. So x minus 2, x plus 2 would multiply together to be x squared minus 4. And then we still have x squared minus 2. This cannot be broken down because 2 is not a perfect square. Now we're going to use the 0 product property. Whenever we have it in factored form equal to 0, we can solve it by the 0 product property. That means one of these terms has to be a 0. Either the 2x has to be a 0, or the negative 2 has to be a 0. The positive 2, or that's x minus 2 and x plus 2. This is x squared minus 2 could be 0. One of those has to be 0. So we just go through and solve like usual. I divided by 2 and I got actually 0, not 2. This should be 0, of course. 0 divided by 2 is 0. Added the 2 to both sides, and x is 2. Subtracted the 2 to both sides and got negative 2. And then this is a little weird, but we get x squared equals positive 2. Then we take the square root of both sides, and that gives us x equals plus or minus the square root of 2. So we have 1, 2, 3, 4, 5 different answers. Because this is a fifth power, we could have up to 5 answers. Let's try the next one. I notice my largest exponent has a negative leading coefficient. So I'm going to add that to the left-hand side. So now I have 6x to the fourth minus 27x cubed minus 15x squared equals 0. Here I notice that all these numbers are divisible by 3, and they also have an x in every term, my smallest exponent squared. So I'm going to pull out a 3x squared. That's going to leave me a 2x squared minus a 9x minus a 5. And there's two ways that we could handle this. We could use guess and check, which would be ideal. It's really what we'd like you to do. That means you're going to use parentheses. You're looking for two numbers that multiply to be 2x squared. Those two numbers are going to multiply each other to make 2x squared. That, of course, is 2x and x. Then you think about two numbers that multiply to be negative 5. Well, it's nice. Negative 5 is a prime number also. So it's either going to be negative 5, positive 1, or it's going to be positive 1, negative 5. It could possibly be negative 1, positive 5. So we got to figure out which one of those ways. This is where the guess and the check come up. Where is the 5 going to be? Well, I've got to get to 9. How am I going to get to 9? If I did 2 times 1, and then I added it to 5, that would get me to 6, not to 9. If I did 5 times, actually 2 times 5, that would get me to 10, and the 1 could possibly get me to 9. So if this was a negative 5 and a positive 1, then that's going to FOIL together to give me my original problem. That's called guess and check. If that's too much, then we always have our factor by grouping method, where we take our 2 times our 5 to get negative 10, what adds to be 9. You know your two numbers have to be different signs, and the larger one has to be negative. So 1 and negative 10, 2 and negative 5 are the only ways you can multiply to be negative 10. So this is the way that we're going to add to 9, because this one adds to negative 3. So we're going to put our 1x and our negative 10x in place of the 9x. That's going to give us a 2x squared with our positive x minus 10x minus 5. So these two terms come straight down. And then we do our factor by grouping. So when you do factor by grouping, we factor out what we have in the first group here, which is x. That leaves us a 2x plus 1. Bring down your sign. Factor out what you can. 2x. Negative 5 times 2x makes negative 10x. Negative 5 times a positive 1 makes a negative 5. So this is x minus 5 and 2x plus 1. And don't forget your leading coefficient out in front. So here we're going to do our zero product property. (3x squared equals 0), x minus 5 equals 0, or 2x plus 1 equals 0. The zero product property tells us that either this term or the middle term or the last term, one of these has to multiply to be 0 if it's going to have a product of 0. So when you take the square root of 0, you get 0. And you subtract the 1 and divide by the 2. All right, so now we're going to factor these to help us figure out the zeros so we can place them on the graph, use our degree and leading coefficient to help us determine how the graph goes. So pause the video, work through this first example, see if you can factor this one, then we'll talk about how it applies to the graph. We've done this type of thing before. All right, we're going to circle our first two terms, circle our last two terms. Remember, or recognize, that this has 4 terms to it. And in our notes it mentions that if we have 4 terms, we're going to factor by grouping. So, we're going to give this a try. They do have an x in both of them. They have an x squared as a smaller exponent, so I can factor that amount out. X plus 2 is what I have left over. Bring down my negative. There's nothing that factors out of x minus 2, so I'm just going to factor out a 1. So negative 1 times x and negative 1 times a positive 2, those would multiply to give us our negative x minus 2. And we're going to bring these down as x squared minus 1 and x plus 2. Now, since we're trying to find the zeros, we would say f of x is 0. In our equation, we'll use the zero product property to help solve for that. I have the difference of 2 squares here, so that can actually be factored one more time. So we can factor this completely. So using the zero product property, we have x minus 1 that equals 0, so x equals 1. X plus 1 equals 0, so x equals negative 1. And x plus 2 equals 0, so x equals negative 2. Those are the zeros of the function. So when we go to our graph, we're going to be at positive 1, negative 1, and negative 2. Those are the values on the graph that these would stand for. Now when we talk about degree, we're not talking about the 3. We are essentially, but we don't care about the number 3. What we care more about is that it is an odd number. The odd number tells us how it's going to react on our graph. The leading coefficient, we see that that's the number 1 out here, but we don't really care about the 1. It could be a 2, 3, 4, 5. We really don't care what it is, as long as it is positive. That's the main thing we're recognizing. It's a positive leading coefficient. What the positive tells us is that it increases to the right. The odd degree tells us that it's going to go in the opposite direction than what it did to the right. Since the right went up, when it moves to the left, it's going to be going down. We recognize that every one of these zeros is independent. None of them are double zeros. They're not the same number. So all of our zeros, it's going to go right through nice and smooth. We're not worried about how high up or how far down we go. In our end behavior, just like we've talked about before, as x approaches the right, as x, let's say the left, we like to do negative x first. So as x approaches negative infinity, the function f, so f of x, is doing what? When we look to the left, the graph is eventually going down to negative infinity. And if we look far enough to the right, the graph will be going up. Here's a U try, so go ahead, pause the video, try to factor this one. Identify the degree, the end behavior, and the leading coefficient. So to start this one off, I notice that we have two terms. I see that this is not the difference of two squares. This is not the sum of two cubes. I can't take the cube root of 4. So it's not following those patterns. It does have a GCF. Because it's a leading coefficient that's negative, I'm going to pull out a negative. I'm going to pull out an x squared. That's going to leave me an x plus a 4. We're going to set this equal to 0. We'll use the zero product property since that's fully factored. I could divide by a negative and then take the square root. So x squared equals 0 and take the square root of both sides. So x is going to be 0. You could consider this a double 0. Okay, it's a double 0 because you have x squared. It's x times x makes 0. Either one of those is 0. But over here, x is going to be 4. Actually, negative 4. Nope, that's not right. Because the negative times the x is going to give me negative x cubed, and the negative x squared times a negative. Sorry. Did you realize that? That a negative times a negative is going to make a positive. So this is in fact going to be x equals 4. So we have a 0 and we have 4. I notice my leading coefficient of the original problem is negative. So that means my graph is going to be falling to the right. The degree, it's a cubic, so my degree is odd. So that means it's going to be going in the opposite direction than it does to the right. Now I recognize that I would have some troubles if I just went all the way through. I can't just curve up anywhere I want to. That doesn't work right. Because of the double 0, that tells us that it's going to bounce It's going to bounce at the 0 because x squared equals 0. That's considered a double 0. Just like we talked about earlier this year. As x approaches negative infinity, the function is going up. As x approaches positive infinity, the function is going down. Okay, our last question. Looking at a jewelry box. We know that a jewelry box is going to be what we call a rectangular prism. This jewelry box is. So the volume of it is going to have the length, we'll call that the front side, the width, how far back it goes, and the height, x minus 3. So we know that volume, this is a volume question, is going to be length times width times height. That's how you calculate the volume of a rectangular prism. They're calling it a box. That's not very specific, but 24 is the volume. Now, I'm not going to worry about the order of length times width times height. I like to put the monomial first. Then one of my binomials, then the other binomial. Many different ways you could think about this in terms of multiplying. We cannot set each of these terms to equal to 24. That's the common mistake. You've got to move everything over to the same side of the equal sign. So we're first going to FOIL this together. So we still have 24, we still have 2x, and we're going to get x squared. Negative 3 and negative 1 gives us negative 4x plus 3. Then we're going to come through and distribute our 2x through. So that's 2x cubed minus 8x squared plus 6x. Then we're ready to move our 24 across. So we have 0, and we have this cubic equation. It's in standard form. So what we need to do is realize that this cubic equation is going to have 4 terms. That means we can use factor by grouping. We can factor out our 2x squared, leaves us x minus 4. Bring down your sign, factor out what you can. X minus 4. So we have 2x squared plus 6 and x minus 4. We're going to set each of these equal to 0. So 2x squared plus 6 equals 0, and x minus 4 equals 0, because we're using the 0 product property. So subtract your 6. 2x squared equals negative 6. Divide by 2. X squared equals negative 2. And when we take the square root of both sides, we're taking the square root of a negative, which means we have to say I root 3, which means this is an imaginary answer. It's not a real one. We only want the real ones in geometry. Here we get plus 4, and there it is. There's your real answer. 2 times 4 gives us 8. 4 minus 1 gives us 3. 4 minus 3 gives us 1. that multiplies together to be a volume at 24.